Hello everyone. Good evening. Good evening. Good evening. Okay. As I can see, there are very fewer number of students are there. Good evening. Good evening. Shivani. Okay, vibe status. Okay, so I hope students are aware regarding this MAHA series, and after the passing of time, the strength will be there in our class. So let's get started. As you can all see, it's the time for the MAHAMARAATHON, and the topic for today is going to be, the subject is organic chemistry, and the topic of today's marathon is reaction intermediate, inductive effect, resonance, electromeric effect, and the hyperconjugation. So this is the topic from where we are going to see the 50 multiple choice questions, 50 MCQs, and I hope you give the answers of each questions correctly. This is going to be the third MAHAMARAATHON class, third class, and after the completion of this, I hope we will be able to solve all the 500 questions. Okay, so in each class we are having 50 questions. So after the end of this class, this MAHAMARAATHON will be having 500 questions completions. Okay. All right. So let's get started about this today's marathon. All right, so this is the weekly schedule of your marathon. You know very well, like today it's the 9th of January, and from 9th, just after a few days, you will be having your revision test number 2 on this Saturday to Sunday, and I hope you all give this test, you all participate in this kind of test series. This is totally free of cost, and it's only and only designed for the perfect score for your GPAT examination. So yes, you must be present on in all this revision test. Let's get started with our first question. The first question for today's marathon is, which of the following cannot react as a nucleophile? So among given all the options, what do you think, which of the given will not be acting as a nucleophile? So nucleophiles are those species which are having electron pair donating properties, electron pair donating tendencies. Nucleophiles are species which are having higher electron densities, then only they are able to donate the electron pairs. So here you can see we are having 4 times methyl group with the nitrogen. Here we are having CH3NH2 group. Here we are having CH3 ka whole twice NH. This is the tertiary nitrogen. So here the nitrogen is 3 degree, here 2 degree, here 1 degree, and this is 4 degree nitrogen. Among all these 3 nitrogen groups, we can see in this cases, the nitrogen will be having, they must be having at least a lone pair. Here 2 methyl groups. And for the first, like the last one, it will be having the at least lone pair on the nitrogen. What about this one? Here the nitrogen is in positive charge. So this can never act as a nucleophilic center. There is no any chance for the nitrogen of this one to be acting as a nucleophile. It is not having electron density higher due to absence of lone pairs. So this can never act as a nucleophile, and the question is, cannot react as a nucleophile. Which of the given cannot react as a nucleophile? So yes, A is the right answer. This 4 degree nitrogen atom can never have a lone pair of electrons, so can never act as a nucleophilic center. Okay, all right. Moving ahead, let's go to the next question. The next question, that is, electron pair of the pi bond is moved towards the attacking reagent due to. So the pi bond of a pi bond of a compound is moving towards the attacking reagent, this phenomena, this property is known as, so this is plus E effect, plus I effect, minus E effect, or the minus E effect. So among all this, you can see the pi bond is moving. It means the pi bond must be breaking. Suppose you are attacking the reagent and the reagent is of a positively charged species. Let's suppose it's an electrophilic kind of reagent. So this electrophilic reagent can be only attacking to that double bonded carbon that is having higher electron density. And you know very well the alkene system or the alkyne system, the carbon-carbon double bond or the triple bonded systems are acting as a nucleophilic centers. Here, if we transfer this pi bond over this carbon, so we can have this kind of structure, like this carbon will be having a negative charge while the other one will be having the positive charge. So this electrophilic reagent, if this electrophile have to attack on the double bonded system, if this is attacking here, it means this must be gaining the negative charge. The pi bond must be shifting to that double bonded system. So this is the hydrogen and this will be having the positive charge. So if the attacking reagent is attaching to that double bonded system where the pi bond is shifting to that atom, to that particular atom, such a kind of groups can be termed as the plus E groups or the plus E effect. Plus E effect. So this is actually a plus E effect where this is a electromeric kind of nature. This reagent polarizes the pi bond of your substrate only and only for a small interval of time, just to be having the condition to be bonded with. So this is known as the electromeric effect. This is the a temporary polarization of the pi bonded compounds over the demand of the attacking reagent. So that is known as the plus E effect. This electrophilic reagent can be only having tendency to attack to that double bonded system where the pi bond is moving. So this is the plus E effect. Plus E effect. So yes, A will be the right answer. A will be the right answer. Yes, A is the right answer for this question. Moving ahead, we are having a statement based question. Which of the following statement regarding the electrophiles and the nucleophiles are correct? So we are having the first statement as electrophiles are electron deficient species and act as a Lewis acid. So electrophiles are electron deficient species. Yes, they are having higher tendency to be accepting the electron pair. So yes, they are actually electron deficient centers. So that's why they are termed as the electrophiles. That is, they have love for the electrons. And they are acting as a Lewis acid. Yes, they are acting as a Lewis acid. The reason is if they are having deficiency of electrons, they must be having the electron pair accepting properties. So yes, they are actually electrophiles and they are having no electron deficient centers, and yes, they are having the Lewis acid properties. So the A statement is right. The first statement is the very right. Charged electrophiles are positively charged species with the central atom having an incomplete octet. Yes, very well. The charged electrophiles, it means again we are having the property of the electrophiles, that is electron loving species. They are having deficiency of the electrons. So yes, they must be having the positive charge. So yes, they are positively charged species with the central atom having incomplete octet. Yes, they are having electron deficiency. It means they are having less electrons and they are having incomplete octet. So yes, that is also a right option, means a right statement. Nucleophiles are electron rich species and act as a Lewis base. Yes, very well. Just inverse of the electrophiles, we will be having nucleophiles acting as electron rich centers. They must be having the electron donating properties. Yes, they are having electron pair donating tendencies, so they can be termed as Lewis bases. Organic compounds with multiple bonds such as alkenes or alkynes can act as a nucleophiles. Yes, if we are having carbon-carbon double bonded system or carbon-carbon triple bonded system, this is actually the result of this one. We are having this kind of pi electrons, while for this one we are having one on this and the other on this phase. So they are having higher electron densities between two carbons in the alkenes and the alkynes. So they are acting as a nucleophile. So all the statements given here, 1, 2, 3, 4, all are correct. All are correct. 1, 2, 3 and 4 all are correct. So yes, that is C is the right answer. C will be the right answer for this question. Yes, C is the right answer. Now we are matching question inductive effect. So inductive effect is, so it's a permanent effect where the displacement of sigma electrons is seen, and it's a distance dependent. So what is the actually here in the list 2 we are having interaction of sigma electrons with the pi bond. So either the sigma pi or the sigma p. This is regarding the hyperconjugation. So let's match this p with the 3 1. So p third. So 3 with the p only in one case. Okay, so this is all incorrect. Permanent displacement of electrons. So permanent displacement of electrons, it means it's belonging to the inductive one. So yes, that is also the right one. So first we'll be having the Q. Yes, that is matching here. Mesomeric transfer of electron in a conjugated system. Yes, that is very well. Okay, that is correct. And electromeric temporary effect due to attacking reagent. Yes, that is a temporary effect. Only the electromeric effect is a temporary effect. It is actually seen only and only when we are having some reagent on the demand of the attacking reagent, we see the polarization in the substrate molecule. So yes, in the fourth will be S. So yes, only and only it is belonging to the C, that is having the all correctly matched options. So yes, that is the right answer. That is the right answer. C will be the right answer for this question. C. Okay. Long time no see. Okay. I guess we are having this marathon after just 4 or 5 days. We were having the first marathon on the first. Okay, so after the first, haven't we seen any marathons in English? Okay, I hope we will be sharing the question series very soon in the next days, in the few upcoming days as well. So the next question we are having is a carbocation will not show one of the following properties. Choose that. We are having a carbocations C+. It means it is having 3 sigma bonds. So which of the following is not the property? It accepts an electron to give carbene. No, the first is wrong. Why the first is wrong? Carbocations are already having 6 electrons due to 3 sigma bonds formations. Due to presence of 3 sigma bonds, this carbon is already having 6 electrons. So if it is accepting an electron, it is not possible for this carbocation to be acting as a carbene. As we knew, carbenes are having 6 electrons and they are acting as electrophiles as well. So the first one, that is accept an electron to give carbene, this is incorrect regarding the carbocations. So you are asked not shown. So yes, that is not correct. So yes, this is the right answer for our question. Elimination of a proton to afford an alkene. Yes, very well. During the elimination reactions in the E1, after the formation of a carbocation, we see a elimination of the proton to be having a alkene formation. So yes, that is correct. Combined with a negative ion. Yes, carbon is having positive charge, so it must be having tendency to be reacting with a nucleophilic reagent. So either a lone pair or a negatively charged system. So yes, that is also correct. Abstract a hydride ion to form an alkane. Since this carbon is having positive charge, so it must be having tendency to be reacting with a H minus hydride, so that alkane formation can be seen. So yes, that is also right answer. These all 3 statements are correct regarding the carbocations, while the first one is not. So yes, A will be the incorrect statement. Okay. So A will be the right answer. A will be the right answer for this. And as you all know, the next revision test is on the 10th of January. You can say tomorrow. So you must be joining this test series. If you haven't joined till now, you must enter the batch code MAHA in the small case with 26 without any space. So you will be able to join to this test series in this batch, and you can able to see the questions and attempt the questions regarding this revision test. Moving to the next question, let's have the next one is, which of the following having a highest pH value? Highest pH. So pH is highest for base. The bases are having high pH value, while for the acids the pH value is low. For the acid, the pH value is low. 0, 1, 2, 3, 4. This is regarding the acids. And as you move on, as the pH number increases, it means the basic nature is actually increases. Okay. All right. So this is benzoic acid. This is benzoic acid. It's the acid. Okay. This is aniline. Yes, aniline is known as a better base than the benzoic acid. So which of the given structure will be having the highest basic value, highest base strength, highest basicity? That is going to be having the highest pH value. Here we are having again nitrogen is having basic nature, but here the nitrogen lone pair are busy in the benzene ring, as well as there is one conjugation existing between the NH and the C double bond O. So due to extended conjugation, this nitrogen's lone pair will be having the weaker base strength than comparing to the aniline system. So this is having the poor base strength than this one. And here we are having the phenol. Phenols are a base. Phenols are having the mild acidic nature. So yes, this is also having the acidic character. So the highest pH value you can see is in the aniline. Aniline will be having the highest pH value due to most basic compound among all these given four. Most basic, it means you can say highest pH value. Highest pH. While this benzoic acid will be having the least basic. Least basic. It means least pH value. Least pH. So the most or the highest pH is for this B1. That is the aniline. That is the aniline. That is the aniline. So yes, that will be the right answer. That is the right answer. B will be having the highest pH value. Most basic compound. Read the following statements about the characteristics of the carbanions. They are nucleophiles. Carbanions, yes, they are nucleophiles. They are having higher electron density due to presence of the negative charge. Due to presence of the negative charge. They are diamagnetic. Yes, they are having all the electrons in paired form. They are having 8 electrons and all the 8 electrons are paired. So yes, they are acting as a diamagnetic substances. That is right. They are Lewis acid. No, Lewis acid is the condition for the electrophiles. The compounds that are having electron pair accepting properties, they are electrophiles. So this is incorrect regarding the carbanions. They have sp2 hybridizations. No, they are having, carbanions are having sp3 hybridization states. So that is also incorrect. So P and Q are correct while R and S are incorrect. P and Q are true. Okay, so in the last option, look in the D option, P, Q are true while the R and S are false. So D will be the right correct combination for this question. D. Which is ion shows maximum resonance stabilization? Maximum resonance stabilization means the maximum resonating structures. CH3 C double bond O. So here the C double bond O is having the resonance between just C double bond O and O. This CH, this one O minus. So this will be having resonance with the ring itself. This no resonance, no resonance. So in all these C and D, there is not at all any resonance happening. While in the A and B, you can see here we are having greater number of resonating structures. So B will be having higher resonance stabilizations due to better resonance, due to greater number of resonating structures. Greater number of resonating structures. Okay. So yes, B will be the right answer. Hyperconjugation involves overlap of the following orbitals. In the hyperconjugation, we see sigma overlapping with the pi orbitals or the sigma overlapping with the p. So when we are having case for the carbocations, the positive charge, or for the radicals or for the free radicals, this is seen in the sigma and p. And when we are having the alkenes stability, that is we see in the sigma and pi. So sigma pi or the sigma p. Pi, no, this is regarding the resonance. Pp, no. Sigma p, yes, that is correct. Sigma, this is regarding the inductive. So for the sigma interaction, inductive effect. For the pi, we see the resonance. While for the sigma p or the sigma pi, this is regarding the hyperconjugation, also known as Baker-Nathan effect. No bond resonance, sigma pi resonance, sigma p resonance. This is all. Okay, so B will be the right answer. B will be the right answer here. Which of the following statement is correct regarding nitrines and the benzynes? Nitrines are electron-rich species. Nitrines are electron-rich species, making them strong nucleophiles. Benzynes and the nitrines. Dear, nitrines as well as the carbenes, both of them are having 6 electron systems. It means they are electrophiles, not nucleophiles. What is written here? Nitrines are electron-rich species. That is incorrect. Benzynes are neutral intermediates. Yes, that is correct. Formed during nucleophilic substitution of aromatic compounds. Yes, that is correct. For the benzynes formation, suppose we are having Cl and we react this with the NH2 minus. What this NH2 minus is actually happening here is this H plus is abstracted by the NH2 and we see a positive charge here for this bond is shifted, the hydrogen bond is shifted towards this, let's suppose in the form of negative charge, and we are having the Cl attached here. So electron pairs of this negative charge is moved for the pi bond formation and the Cl is removed from this case. So we see this, that is the benzyne, that is 1, 3 and we are having 1, 3, 5. At the 1, 3 we are having diene and the 5 we are having the ine system. So this is regarding the nucleophilic substitution reactions when we are seeing in the aromatic compounds and we are having the benzyne intermediate formation. So yes, that is the right one. Nitrines have a complete octet. No, they are having incomplete octet, 6 electrons, so no octet complete. Benzynes lose their aromaticity. No, the aromaticity is maintained, retained in the benzyne intermediate. So yes, B will be the right answer. B is the right answer for this question. So yes, B will be the correct option. Which compound shows maximum resonance stabilization? So the maximum resonance stabilization is present in benzene, naphthalene, anthracene or the aniline. So for the benzene we are having just one benzene system. In the naphthalene we are having 2 benzene systems fused. So this is the naphthalene. In the anthracene 3 benzenes fused together. 3 benzenes fused together, giving you a better resonance stabilization due to 3 benzene resonance. And in the aniline just a 1 benzene with 1 NH2 group. So the maximum resonance you can see is in the anthracene due to 3 benzene ring system. So yes, C will be the right answer. That is the anthracene. C is the right answer. That is the anthracene. C will be the right answer for this question. That is anthracene will be having the maximum resonance stabilizations. Next we are having choose the correct option. Now the assertion is tertiary carbocations are more stable than the primary carbocations. Yes, the tertiary carbocations are having higher number of alpha hydrogens and due to better hyperconjugation stabilizations, this will be a better stable compound than the primary carbocations. Alkyl groups shows plus I effect which stabilizes the positive charge. So yes, the inductive respect is also very well correct. So due to greater number of alkyl groups, better plus I nature will be seen, and due to better plus I, stability of the positive charge will be increasing. Plus I are the compounds that are having electron donating groups property, electron donor. So yes, both the assertion and reasons are the true, and reason is correctly explaining your assertion. So yes, A will be the right answer for this question. A is the right answer. Mesomeric effect involves the delocalization of. So in the mesomeric effect, we see delocalization of the electrons. We see delocalization of the electrons. Suppose we are having the aniline. So here we will be having the lone pair. This lone pair moves here. So the electron will be shifting here. This one, and now this moves here. So this pi bond moves to the next carbon. So this one and negative on here, and the pi bond is placed at, oh my bad, the pi bond is placed on this position and the negative charge is seen here. Now the negative here, so the pi bond is broken to form a negative charge. This one and negative here, and now again this and this, giving you the again this one structure. So only and only in the mesomeric we see the delocalization of electrons. Either it could be lone pair, negative charge, pi bonded, such kind of electron pairs. So protons no, sigma electrons no, never sigma electrons are delocalizing. There is no any relation between the sigma electrons or the sigma bond with the resonance. So that is incorrect. Pi electrons and the pi bond orbitals. So there is no any pi bond orbitals. So we see only and only pi electrons. So C is the right answer. C for cat, yes, that is correct. Pi electrons. So yes, this C will be the right answer. Which of the following group increases stability of carb anion? So the carb anion stability is increased by minus I or minus M groups. So better minus I or minus M stabilizes the stability of the carbon ions. So stability of carbon ions is directly proportional to the presence of minus I or minus M groups. Inversely relation with the plus I and the plus M. This is about the carb anions. And for the carbocations, the better plus I or the plus M group stabilizes the stability of carbocations, while the minus I and the minus M destabilizes the carbocations. So this is plus I group. So no, this can't be stabilizing nature over the carbon ions. NO2, yes, CN, yes, CO. Okay, so all of them are having strong minus I as well as strong minus M natures. So yes, that is right. Alkyl, no, not at all possible. While here plus M, again a plus M. So all these, this can never have stability of the carbon ions. Only and only the B option will be having the stability for the carb anions. So B will be the right answer. Yes, very well. B will be the right answer for this question. Ammonia is isostructural with. So structure of ammonia is similar with carbonium ion. So the carbonium ion is like this one. Okay, so this one, that is trigonal planar. Carb anion, so yes, carbon, H, 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 and the negative charge. So yes, this will be also looking like something this. Free radical, the same, one electron on the place of positive charge. Carbenes, it could be either singlet or the triplet. So if it is singlet, this will be looking like something this one, or if it's triplet, it will be this one or this one. So one electron and the one electron. So this is the triplet carbene, this is the singlet carbene. So all others are incorrect. Just ammonia and the carbon ions are having both the pyramidal shapes. Okay, so yes, B will be the right answer. Isostructural with ammonia and carbon ions. Ammonia and carbon ions. The order of basicity of amines in gaseous state. So when the basicity of amines is asked in the gaseous state, it will be 3 degree, then 2 degree, then 1 degree, followed by the ammonia. And if it is in aqueous state, if it is in aqueous medium, if it is asked in aqueous medium, it will be 2 degree, then 1 degree, then 3 degree, and then followed by the ammonia. So this is the basicity order. This will be the basicity order. For the gaseous one, gaseous state, and for the aqueous state. So you are asked for the gaseous, it means 3 degree, then 2 degree, then 1 degree, and then with the ammonia. 3 to 1 ammonia, this. 3 to 1 ammonia. So this will be the basic strength. Sir, if we don't get power proper percentage in M form, then GPAT is 7 will stop. GPAT in the just a second. M form, no. There is no relation with the percentage. If you qualified the GPAT examination and took admission in any M form college to pursue your M form, yes, you will be given the full fellowship. The next question is the correct stability order of the following species. So here we are having the species carbocations. Okay, so the carbocations are having stabilized by the The strongest stability is with the resonance, then hyperconjugation, and the least one is the inductive one. So here you can see is positive charge is in the 3 degree carbon. 3 degree carbon, this is the 2 degree carbon. This is also a 2 degree carbon. And this is the 1 degree carbocation. So the least stability will be for the fourth one. Fourth will be having the least stability. Okay, so all are having arrow on this side. So fourth. Okay, so A can never be the right answer for this question. C can never have the right answer. Either the B or the D is the right answer. Okay, so now let's move. Here we are having 3 degree and this one is having 2 degrees. So first must be having the first place. Okay, so first both are having the right. Now what about this, my dear? Here as well as here, the positive charge is just adjacent to the oxygen, and here we are having the vacant orbital and here we are having the oxygen's lone pair. So they will be having a resonance stabilizations. This will also be having the resonance stabilizations, while here there is no any such kind of resonance present here. So that is why for the carbocations, stability of carbocations, better plus I groups or better plus M groups always stabilizes the stability of, you can say the carbocation stability is increased due to the presence of plus I or the plus M effect, and always resonance is the best stabilization. Then we are having the hyperconjugation, and then followed by the inductive. So here we will be having the first, then we are having the third one due to 2 degree as well as the resonance stability of the oxygen's lone pair with the vacant positive or vacant p orbital of the carbon that is having the positive charge. So first, then third, then second, then fourth, 1, then 3. So no, after 1 here we are having 2 and here we are having 3. So yes, D will be the right answer. D will be the right answer. D will be the right answer. D is the correct answer for this question. Okay? Alright. The most basic compound among the following is acetanilide, benzylamine, paranitroaniline, or the aniline. So most basic. Here we are having acetanilide. Okay? This one and the N and N H C double bond O CH3 nitrogen's lone pair, acetanilide. Benzylamine, the best one. Benzylamine, the best one, best base. Paranitroaniline. Okay. So we are having aniline, and on the para position we are having the NO2 group. Paranitroaniline and just aniline. And just the aniline. So no doubt this will be having the basic strength, basic nature due to presence of lone pair. So yes, they will be having the basic property. Lone pair, so basic. Lone pair, so the basic. Which will be the best base? Lone pairs are involved in the resonance with the ring, and also with the double bond O system. What about this one? Lone pair of the nitrogens are localized. They are not involved in resonance. So since they are not participating in the resonance, so they are free to be donated with the accepting a proton. So the benzylamine will be having the most basic strength. This will be the best base among all the given answers. So yes, benzylamine will be having the best answer. Benzylamine, since the nitrogen's lone pair are not at all involved in any resonance, so will be highest available for the H plus donation. Which factor does not affect resonance stabilization? Which is not affecting the resonance stabilization? Number of resonance structure. Better the number of resonance structure, more will be the stability. So this is actually involved. Equivalent resonating structures, always equivalent resonating structures are having the better stabilization. So yes, that is also correct. Number of sigma bonds. sigma bonds are having no effect regarding the resonance. Sigma bonds were only involved in the either in the hyperconjugation or in the inductive effect. So no, never we can have sigma bond participation for the resonance. Not at all possible. Charge separation, when the opposite charges are at farther distance, they are stable, and if the opposite charges are at closer distances, they are always stabilized, and if the opposite charges are present at the far distance, they are destabilized. So yes, that is also involved. So yes, charge separation matters in the stability of the resonance structures. So the C, this is not effect. This is having no effect on the resonance stabilization. So C will be your right answer. C will be the right answer for your question. Which intermediate is involved in SN1 reaction? So which is involved in the SN1 reaction? Carbocation, carbanion, free radical, or carbene? Carbene, no. Free radical, no. Carbanion, no. Either you are having SN1 or the E1. For both the reaction, intermediate will be the carbocation. Intermediate formed will be the carbocation. So A will be your right answer. A is going to be the right answer for this question. Now consider the statements about resonance versus hyperconjugation. Resonance involves pi conjugation. Hyperconjugation involves sigma pi conjugation. Yes, statement 1 is correct. Resonance is having pi positive charge, pi sigma negative charge, pi sigma lone pair, pi sigma free radical. Yes. So yes, that is having this one. Hyperconjugation can have sigma pi. Yes, that is correct. Resonance is stronger than hyperconjugation. Always the strength of the electron density shifting or the separation says resonance is always having the highest power then with the hyperconjugation, and the least one will be for the inductive. Least one will be for the inductive one. Okay, so yes, that is the right answer. This is also statement correct. Both are temporary effect. Just a second. Either resonance or the hyperconjugation or the inductive. This all these three are having permanent effect. They all are permanent effects. They all are permanent effects. While the electromeric is having the temporary effect. So yes, this is wrong. While the first and second are true. So 1 and 2 only are the right answer for this question. A will be the right answer. A will be the right answer. Yes, A will be the right answer. Which of the following represents the correct order of stability for the carbanions? Carbanions stability is always decreases due to presence of plus I groups. Resonance always stabilizes the either carbocation, carbanion radicals or anyone. So here we are having, this is the allyl carbanion. We are having negative charge on this carbon, this one. Let's suppose I am having this here. This negative moves here for the making of a pi bond, while this moves here in the form of negative charge. So we can have this one. So negative can be transferred over here. So due to resonance stabilization, allyl will be having always higher stabilizations than other compounds. So no, this is incorrect. This can never have the right answer. Always either this or this can be the right answer. Allyl anions are having always better resonance stabilization, so better stabilized. After this we are having ethynyl anion and the ethynyl anion. Ethynyl anion and the ethynyl anion. So which? Always negative charge is stabilized over a more electronegative atom. And the carbon here and here both are having different electronegativities. Why? The carbon is here will be having the sp hybridization, while the carbon here will be having the sp2 hybridization. So percentage of S character deciding here will be for the electronegativity. So the percentage S character will be high for this one, the 50% S character. 50% S character, while here percentage of S character will be 33%. So due to more percentage S character, this will be having a more and more electronegativity. So this will be a better stabilized anion than the ethynyl. Okay. Then we are having 1 degree and the methyl anion, 1 degree anion and the 3 degree. So yes, that is all right. So the B will be the right answer. B will be the right answer here. B is the correct answer for this question. Now again we are having the assertion and reason. Phenols are more acidic than the ethanol, yes, due to better phenoxide ion stabilization. Due to better phenoxide ion stabilizations as comparing to the CH3, CH2O- in the ethoxide. The phenoxide ion is stabilized by resonance. Yes, due to resonance stabilization, this phenoxide will be having a better conjugate base, stabilized conjugate base. It means it will be having a better acidic strength, means phenol will be a better acid. So yes, both A and R are true, and R explains the assertion very well. So A will be the right answer. A will be the right answer. Again we are having triplet carbene is more stable than the singlet carbene. The triplet carbene is this one. 1 electron and the 1 electron. So the triplet carbene is more stable than the singlet one. This is the singlet carbene. Singlet carbene, okay. Bigger p orbitals. Hybrid will be the smaller one. This one, and here 2 groups are present, and these are the free vacant p orbitals. Vacant p orbitals. 2 electrons are here. 2 groups, let's suppose A and B are present here. A and B are present here. So here in the triplet one, both the electrons are on the different unhybrid p orbitals. While for the singlet, both the electrons are present on a hybrid orbital, while one of the unhybrid orbital is empty. So triplet is more stable than the singlet one. In triplet carbene, the 2 unpaired electrons, occupy separate orbitals, reducing the repulsions. Yes, that is correct. That is correct. That is correct. So both assertion and reasons are true, and R is explaining assertion very well. So yes, A will be the right answer. A will be the right answer for this question. A. Again, we are having a statement based question. Resonance structures differ only in the arrangement of electrons. So the resonance structures differ in the arrangement of electrons. That is correct. The actual molecule is a hybrid of all the resonating structures. Yes, that is also correct. Let's suppose we see for the benzene. So benzene is having 2 𝘾𝙀 structures. This one, and this one. And its a hybrid structure is this one. Hybrid structure, okay. So hybrid. So yes, that is also right. More the resonance structures, less the stability. Just look at this one. If the resonating structures are high, the stability will also be the higher. So this is incorrect. So statement 1 and 2 is correct. 1 and 2 only are the correct. 1 and 2 are correct. Right? The third statement 3 is wrong or incorrect, you can say. Hyperconjugation involves the delocalization of. So in the hyperconjugation, what kind of delocalization is seen? Sigma electrons only. This is regarding the inductive effect. Pi electrons only, no. Only pi electron delocalization can be seen for the resonance. Sigma electrons with adjacent pi or p orbital, yes, that is correct. That is why we see sigma pi or the sigma p conjugation is the other name for the hyperconjugation. Lone pair electrons only, no, that is incorrect. So C will be the right answer. C will be the right answer. So yes, C is the right one. Homolytic fission of a hydrocarbon liberates. So the homolytic fission always liberates free radicals. And the heterolytic fission, while a heterolytic fission always have ions, charge. So the homolytic fission will always have free radical formation. C will be the right answer. C is the right answer. The inductive effect operates through pi bond, operates through sigma bonds. Yes, that is correct. Permanent and increases with distance. No, it decreases It decreases with the distance. Yes, this is permanent, but not increases. Rather, it is decreases with the increase in distance. It is temporary. No, temporary is regarding the electromeric. So this is incorrect. This is incorrect. This is incorrect. It operates through sigma bond. It is permanent effect. It decreases with the larger distances. Okay, so yes, B will be the right answer. Which of the following is a correct order of stability of free radicals? 3 degree, 2 degree, 1 degree, and the methyl allyl is in the last place. Dear, allyls are having resonance stabilizations. So a resonance stabilized radical will be having more stability. This, okay. So the resonance stabilized radical, that is the allyl radical, will be more stabilized than the 3 degree, then the 2 degree, and then the 1 degree. Why 3 degree? 3 degree is having 9 alpha hydrogens, 2 degree is having 6 alpha hydrogens, 1 degree is having 3 alpha hydrogen, 0 alpha hydrogen, while this is having the resonance stability. So the resonance will be having the more stabilized. Resonance always the highly stable. Okay, allyl here, resonance stability, then 3 degree, yes, then 2 degree, yes, then 1 degree, and then the methyl. So allyl due to resonance more stabilized, then 9 alpha hydrogen, 6 alpha hydrogen, 3 alpha hydrogen, 0 alpha hydrogens. D is the right answer. D is going to be the right answer for this stability of the radical. Due to the presence of an unpaired electron, free radicals are, due to presence of unpaired electrons, it is paramagnetic species, it is highly reactive, it is short-lived fragment, it's reactive intermediate, all this. Chemically reactive, yes, that is correct. Chemically inactive, no, it is chemically very reactive. Anion, no, this is not about the charge. So radical is not any kind of charge. So no, this is not an anion or cation. This is chemically highly active. It is having higher tendency for the reactions. So that is also incorrect. So only chemically reactive is going to be the right answer. So A will be the right answer for this question. A. Okay, statement again. It is regarding the Baker-Nathan effect, that is also known as the hyperconjugation. So Baker-Nathan effect, that is also known as the hyperconjugation. Hyperconjugation. It is related to the hyperconjugation. Yes, statement 1 is correct. Number of alpha hydrogen decides the stability. Always number of alpha hydrogens. Number of alpha hydrogens always. Number of alpha hydrogens always stability stabilizes the carbocations, stabilizes the radicals, as well as stabilizes the alkenes. So better the number of alpha hydrogens, more will be the stability of carbocations, more will be the stability of radicals, and more will be the stability of alkenes. So yes, that is correct. It is permanent effect. Yes, that is also correct. Hyperconjugation is a permanent effect. Inductive is a permanent effect. Resonance is a permanent effect, while the electromeric is a temporary effect. So all the statements are correct. All the statements given here are correct. This is the right answer. This will be the right answer. Next, which statement about resonance is false? Which statement is false regarding the resonance? Resonance structures differ only in electron positions. Yes, that is correct. Resonating structures will be having electron separations. Only and only the differences is due to the presence of electrons. So that is right. Atoms move during their resonance. No, the first condition for a compound to exhibit resonance is not be having any kind of atomic movement. So yes, this is incorrect, false. Atoms do not move, So this is incorrect, and yes, you are asked regarding the false. So that is the right answer for your question. All resonance structures contribute to hybrid. Yes, all the resonating structures contribute to your hybrid structure. More resonance structure means more stability. Yes, that is also true. So A, C, D are true, while the B is false. The B is false. B will be the incorrect option. B is the false statement. Which of the following shows plus I effect? Nitro is having strong minus I nature. Cl is having the strong minus I nature. CH3OO plus I group. Carboxylic minus I. Alkyl groups. All alkyl groups are plus I, or you can say electron donating groups. donor groups. Electron donor groups. Okay. While here nitrogen due to strong electronegativity always shows minus I nature. Here carbon due to making bond, triple bond with the nitrogen. This is also having the higher electronegativity, so strong minus I nature. Carbon bonded to double bond oxygen, minus I nature. Okay, so the alkyl will be having the plus I nature only among all these four options. Okay. Next we are having is read the following statement and choose the correct one. Tertiary carbocations are more stable than the primary carbocations. So the tertiary carbocations are more stable than the primary carbocations. Okay, tertiary carbocations more stable. Yes, that is correct. Tertiary carbocations are having more alpha hydrogens. Yes, that is also right. So both the assertion and reasons are true, and reason is explaining your assertion very well. That is right. That is right. Next again, propene is more stable than ethane. Propene, CH3, CH double bond CH2. Yes, that is correct due to 3 alpha hydrogens. Propene shows hyperconjugation with 3 alpha hydrogens. Yes, that is correct. While in the ethene, there is no any alpha hydrogen present. So yes, that is also correct. Both are correct and reason is explaining your assertion very well. So A is the right answer. A will be the right answer for this question. The most stable carb anion among the following is, this is one like methyl anion, 1 degree anion, 2 degree anion, and the CCl3 anion. Okay, most stable. Stability of carb anions is due to minus I. So here we are having carbon connecting with 3 chlorines. Carbon having 3 chlorine groups, all showing minus I character. So yes, CCl3 will be having the most stabilizing effect on the carbon ion. So yes, D is the right answer. How many resonance structures does a carbonate ion is having? C, double bond O, O and O minus. So due to presence of 2 negative and 1 pi bonded oxygen, this moves here. So this goes here, double bond O and the O minus. And again this moves here, so this goes here, carbon having O minus and the O minus and double bond over here. So 1, 2 and 3, there can be having 3 structures, 3 resonating structures for the hyperconjugation. So yes, that is correct. That is correct. Which has most of acidic strength? Just 1 plus I group here and better plus I, 3 carbon chain, 4 carbon chain. Acidic strength is directly proportional to minus I groups, inversely proportional to plus I groups. Here we are having the highest, strongest plus I group, a little weak plus I, more weak plus I, weakest plus I. So as the plus I group lowered, the acidic strength will be increased. So due to, you can say, poorest plus I nature of methyl, this will be having the best acid property. The order of decreasing energy of the anion, energy. So the stability of anion will be having the energy inverse relation. The more stable anion will be having the least energy. So the more stable anion, which is the most stable anion here? 3 degree anion, 2 degree anion, 1 degree anion, or the methyl anion. So the methyl anion will be having the most stabilized effect, most stable anion, and this will be the least stable. So the most stable will be having the least energy. So this, and then we will be having the fourth. Okay, so this is incorrect, this is incorrect. After this we will be having for the third, that is due to just 1 degree nature. Here we are having 2 degree anion, 3 degree anion. So 4, 3, 2, 1, 4, 3, 2, 1 here in the B. 4, okay, 4, 3, 2, 1. Decreasing order, okay, my bad. This is having the least energy. So the least energy is here, my dear, okay. This, most, then this, then this. So the highest energy is for this one. That's what we have seen. Least energy is here. So the highest will be for this one. And if this is the highest energy, this is the least. So the least on this, more than this will be on this one, and more this than this, the highest will be for the A. So 1, then 2, then 3, then 4. This is the order. Okay. The A will be the right answer. Yes, yes, yes. Very well. A will be the right answer. That is correct. Next question we are having is the carbonate ion has all CO bond equal length. Yes, due to resonance, all of them will be having the equal bond lengths. The negative charged can be delocalized on oxygen atom through resonance. Yes, that is also correct. Negative charge is moved towards the oxygen. We have just seen the resonance structures. So yes, that is also correct. So A will be the right answer. A is going to be the right answer. Which group shows the strongest minus I effect? Halogen, nitro, carboxylic, or the oxygen? So here we are having the nitro, the strongest minus I, and the strongest minus M as well among the neutral structures. So this will be having the highest minus I nature. Highest minus I nature. Okay. Again, we are having a statement based question regarding the hyperconjugation. It involves sigma pi conjugation. Yes, statement 1 is correct. It explains the stability of alkenes. Yes, that is also correct. More the hyperconjugation structures, more the alpha hydrogens, better will be stabilized, but alkene will be seen. Statement 3, it requires beta. No. It requires alpha hydrogen. So no beta. So statement 3 is wrong. 1 and 2 only are the right one. 1 and 2 are the correct one. 1 and 2. Free radicals are paramagnetic in nature. Free radicals are paramagnetic. Yes, due to unpaired electron, due to odd electrons, free radicals are having the paramagnetic nature. That is correct. Free radicals contain unpaired electrons. Yes, they are having odd electron. Due to presence of odd electron on the free radicals, they are having the paramagnetic nature. It means when they placed on the magnetic field, they get attracted towards the magnetic poles. So yes, that will be having the right answer. That will be having the A as the right answer. Okay. We are having the next statement question. Benzene has all carbon-carbon bonds of equal length. Yes, that is correct. Benzene exists as a resonance hybrid of 2 𝘂 structure. So yes, here we are having the benzene 1 and the second 𝘂 structure, and the resonance hybrid of this 2 𝘂 structures, we see the benzene and all the carbon-carbon bond lengths are having the same partial double bonded characters. So yes, both the assertion region are true, and region is explaining the assertion very well. So yes, A will be the right answer. Which of the correct order of inductive, which will be the best inductive nature? Nitrogen, oxygen, fluorine, NH2ORF. Okay. So due to highest electronegativity of fluorine, this will be having the strongest minus I nature. Strongest inductive nature. So here we are having fluorine on the top, then oxygen, then nitrogen. So FON. Yes, that is correct. Nitrogen, fluorine, oxygen. No. The electronegativity will be F, then O, and then N. Okay. So FON. That is B will be the right answer. B will be the right answer. Okay. If it is NO2, if it is having any NO2 option as well, so NO2 will be here. So NO2, then CN, then only after the carboxylics, then we are having the F. Okay. Then only we will be having the F. Next. Stability of benzyl carbocation is due to. So this is known as the benzyl carbocation. Hyperconjugation only. So there is no any alpha hydrogen present here. So no alpha hydrogen. No alpha hydrogen. So due to no alpha hydrogens, this can never have a hyperconjugation stabilization. Resonance only. Yes, the positive charge is resonance in this ring, with this ring. So yes, resonance only. Both resonance and hyperconjugation. Since hyperconjugation is not present here, so the stability of carbocation is not at all having any hyperconjugation relation. Inductive, no. Due to inductive, benzene will be having a minus I nature. So inductive will be destabilizing the carbocation. So that is also incorrect. Only B is the right answer. Only B will be the right answer. Okay, only B will be the right answer. The minus I effect of halogen decreases down the group. So this is the fluorine, chlorine, bromine, and iodine. So yes, the minus I nature is also having the same. Fluorine, highest minus I, then chlorine, then the bromine, and then the iodine. Yes, that is correct. As we go down the group, the electronegativity decreases, and so does the electronegativity decreases, so the inductive effect will also be having the decreased. Electronegativity decreases down the group, so yes, that is also correct. So both the statements are true. Both the statements are true. Both the statements are true. Both are correct. A will be the right answer. Inductive effect decreases with distance. So inductive decreases with distance. Is it right? Yes, that is correct. After the increase in distance, inductive nature decreases. It operates through space. No, it operates through sigma bonds. Okay, so this is incorrect. Assertion is true. So assertion is true, but the reason is false. Assertion is true, but the reason is false. It does not operate through space. Rather, it operates through the sigma bonds. Sigma bond electrons. Sigma bond displacement of the electrons. Okay, C will be the right answer. Hyperconjugation is more effective than inductive effect. Yes, that is correct. We just have seen resonance, then hyperconjugation, and then the inductive. This is the order. Hyperconjugation involves deglobalization through space. No. Hyperconjugation will be having possible due to sigma p or the sigma pi. So this is not involved due to space. So this is also incorrect. A is true, but the reason is false. A is true, but the R is false again. A is true, but the R is false. Assertion is true, but the reason is false. Okay, and next, consider the statement hyperconjugation in propene, CH3. Okay, so in the propene, we are having 3 alpha hydrogens. This is the alkene, and in the alkene, we are having 1 alpha carbon and 3 alpha hydrogens. So yes, that is correct. There is 3 alpha hydrogens, correct. It can form 3 hyperconjugating structures. Due to 3 alpha hydrogens, it can have 3 hyperconjugation structures. Yes, that is also right. It is more stable than ethene. Yes, that is also true. Ethene is having no alpha hydrogens. So due to no alpha hydrogens in ethene, how can ethene have better stability than the propane? So yes, propane is more stable. Propane is more stable than the ethene. So statement 3 is also correct. So 1, 2, 3, all the statements are correct. All statements are right. All the statements are correct. So D will be the right answer. Okay. All right. So that's all. So this is all about today's MAHAMARAATHON class. I hope you all enjoyed the questions. You have seen, like, yes, the questions are not that tough from this topic if you have built up your concepts. So this is all about today's class. Thank you so much everyone for joining with us, connecting with us. Keep connected, keep learning, and keep motivating yourself that yes, you are able, you can do it. You are the only one who is going to rock one day. Just keep updating each day with just a small portion of syllabus. Like yes, I will be going to have just a 1 to 3. I try from 1 to 3 concepts. You have to go in this manner each day. And now try to figure out like what are the major strengths right now you are having, which subject, which topics you have completed, which points you have done very well, very clearly, and what are the subjects, what are the topics that you are having lacking of, and then you go for that portion. Okay. Yes, thank you. So when you come in, Vijay Media. Yes, Vijay. Very soon. I hope that tomorrow onward we will be back in the English. Okay. No. I am nothing. Okay. All right. Thank you so much for this, and keep connected, keep learning, keep doing good for yourself. Thank you so much everyone. Thank you all.